gRPC. And as many stories in this industry today, the story begins with a monolith. This monolith is, the initial system that Bitso had. Is written in PHP, and it's a very simple thing. Typical monolith, just one big thing, everything tied up together, talking to a database, and that's it. The founders of the company knew that this wasn't, this was an MVP. This was a way to get this thing out the door and start attracting customers, but it wasn't really going to scale, if the company grew and so on. So they had envisioned since the beginning an architecture, something more mature, where you have microservices with their databases, and then, in order to not disrupt the operation, start migrating the logic from PHP into these microservices, and have, keep PHP as the front end, like the entryway, but make PHP talk to these services, right? You cannot really migrate the logic. You have to rewrite it because it's a completely different thing, obviously. But now the thing here is, if you take something from PHP and rewrite it, let's say this thing was written with the paradigm of model view controller. So you have models here talking to the database, and then you can move those models into these services, right? And start moving more and more logic here. And these arrows, from the services to the database, there isn't much you can do about it. This is going to be determined by whatever database you use here. Is going to be the protocol of the database. And you try to put these two things, close by and so on. But because this was the previous architecture, and this is just this little arrow where PHP is talking directly to the database, and now you have this thing in the middle, there was some concern about performance and speed and response times and so on. And well, we cannot do anything about these arrows, but we certainly could do, whatever we wanted here, right? Of course, it's a typical solution, very common, to start writing these things and just use REST or REST-ish interfaces everywhere with HTTP and JSON. But that seems highly inefficient in this environment, because this is not a user-facing interface. This is something internal, right? So there may be maybe to display one page for one user, there may be several calls from here to here to these services. So you need this thing to be very efficient. And so we defined some requirements. What did we need here? Obviously, the first thing we need is something that works both on PHP and Java. We need something that's fast. That was the main concern. And I think we can all agree that fast in this context of those little arrows means three things. There are three possible bottlenecks. Encoding the data that you're going to send. Then, what's the size of this data? Size matters in this case because the bandwidth that you have is finite, is limited. And compact messages will help you, cram as many as you can into the limited bandwidth that you have. So compact messages mean, more messages that you can send per second. And on the other side, on the receiving end, you need something that's fast to parse. You need fast parsing of the messages so that you can decode the data quickly. So these are the three things that you need. Obviously, some binary format will help a lot with this, right? Which JSON is not. And then, on the reliability side, not so much about performance, but you need to find the balance. We need something with well-defined contracts, something that you can specify, this is the data that I want to send. And, especially on the Java side, you have a compiler, you want to validate as much as you can at compile time. And so We need something that where you can define a contract. And by contract, I can even mean just the format of the data. Specify what you're sending, what you're expecting, and so on. Obviously, static typing helps a lot. And so maybe that sounds familiar to you. Maybe there's a solution that fulfills all these requirements, obviously. So as we started shopping around, it didn't take us long to find that, gRPC sounds like a very promising alternative. But there was an issue. No PHP support. I'm not talking about today. Remember, I just said early, very early, like January 2017. And back then, there was no PHP support at all. So gRPC worked for Java. It was version 1.1, I believe. But there was no gRPC for PHP. So there was no way that we could use this. However, the underlying technology, upon which gRPC is built, is protobuf. And protobuf, you could use protobuf on PHP. No gRPC, but just like raw, plain vanilla protobuf, you could use. So we said, well, protobuf still fulfills all of these requirements. Except, gRPC is nice because it takes care of the communication itself. If there's one thing I don't like about protobuf, it's the name. I think it's very misleading. I mean, after you use it, it makes perfect sense. It's, protocol buffers, emphasis on buffers, not on protocol, right? It's not a protocol. It's buffers for any protocol that you want to use. It's protocol agnostic. It's just a messaging format, a way to encode data. But if you don't know what protobuf is, the protocol part of the name is kind of like, you think that maybe it's a protocol of communication, which is not. And so gRPC takes care of the RPC part. And with just protobuf, you need to figure that out for yourself. So we said, okay, what are we going to do? We know what we're going to send through this little arrow, but how are we going to send it? I had previous experience working with other protocols. One of them is ISO 8583, the one that's used in finance a lot, for the credit card terminals and so on. And it's a similar thing. I honestly don't know if maybe protobuf was kind of inspired by the design by this thing, because the format is such that it's very efficient to parse as well and everything, but it's more limited than protobuf, I'd say. It's not as versatile because it's oriented towards one thing. It's not general purpose. And but anyway, the usual way that you send these kind of messages here in an asynchronous socket is something like this. With the ISO thing, you usually use 16-bit integers. We went with 32-bit integers so that we were not limited to 64 kilobytes in a message. And so what we do is you have a protobuf message. You encode it and you measure it. And it's like, let's say that it's 600 bytes. Then you have to encode the number 600 as a 32-bit unsigned integer. And you send that. So the receiver knows to first read 4 bytes, interpret that as an unsigned integer, and that tells you the length of the message that's coming after that. You read those many bytes. And the reading part is just that. Read 4 bytes, interpret it as a number, and then read the rest of the message, and so on. It's a loop. And then we said, I started doing tests with this, and it worked nice. But the first obstacle that I had was, I didn't know this at the time. Protobuf does not encode the message type inside the message itself. We know that it doesn't, that's why it's so compact, right? It doesn't encode like the field names or anything, but it doesn't even encode the message type. So you need to know what they're sending you on the receiving end to be able to parse it so that you can use the proper parser for that message type. Otherwise, you cannot map it to your messages, and it kind of loses, one of the best features about it. So I thought, well, what if this service, what if I need to receive like 3 or 4 types of messages, right? 3 or 4 different request types. It wouldn't be practical to open one TCP port per message type. I mean, it's gonna look like, I don't know, like Swiss cheese or something. So I thought about this, and we came to the conclusion that, well, we can always send one request, which we need to like wrap the protobuf in another protobuf message. So any message that you want to send, you encode it, and then you wrap it in a very simple request, which is just called wrap request. And then you put the message here. It's an array of bytes. And you include the message type. Let's say a login request. So there's a wrap request. You're always reading wrap request. And inside there, it says login request and the encoded message. How do you interpret that? We, for the low level stuff, managing sockets, because it's just plain TCP sockets, no HTTP or anything. We wrote the server using Netty. If you're familiar with Netty, it's a very efficient and very, very cool networking library. So we had a Netty server which can asynchronously receive the connections and the requests. And with Netty, this component receives a wrap request. And then we wrote, Netty has this concept of handlers, the message handlers. More than that, it has this concept of a pipeline in which there are several components which can be parsing the message and processing a message as part of a pipeline. So we even had components here. There was a component that could read, a 32-bit integer to determine the length of the rest of the message, because that's a very standard thing. So we didn't have to write that. And there was a protobuf parser also as part of Netty. So we just added a protobuf parser for wrap requests. And then these parsed wrap requests, we have to send them to someone else. So we created our own handler, which is called a message router. And this router is the one that can, well, it doesn't process the messages themselves, but it kind of delegates them to this thing that we wrote called request processors. So these request processors, each processor can handle only one request type. So there's gotta be here one request processor for a login request, and another one for a logout request, and another for a create account request or whatever. So you can have as many as you want here. Each one of these has 3 things. The message type, it knows the message type that it must process. It has the parser for that message type, and it knows how to process it. So you register these components with the message router, and then the message router will look when it receives a wrap request and it says inside, oh, I contain a login request. It needs to go and look up inside, it has a map with request processors, and says if it finds a login request processor, or rather a processor for this kind of request, it gets the parser from it, and then it can parse the request, the array of bytes that was inside the wrap request. And that will give it, finally, with that you instantiate a login request, and you give it back to the processor, and then it processes it however it sees fit. It can do it synchronously, asynchronously, or whatever. The message router is done at this point. It just gives the message to this guy, and that's it. It runs that in a thread pool, so that this is not stuck. If in case these components process things synchronously, this one will not be stuck waiting for the response. And basically that was it. So that's pretty much the server side, right? On the client side, our client, if you remember, the client side is going to be PHP. you cannot, nothing personal against PHP, but it doesn't lend itself very well to do like very elegant stuff. You can do clean stuff with it, but so we settled on a prototype of trait. It turns out I discovered, I learned a lot by writing this thing. PHP has traits. Traits are like interfaces, but they can have methods with implementations in them, and they also can have fields. So we wrote this thing called the prototype of trait, and it handled, it created the low-level TCP sockets to the services that it needed to connect to. It knew how to wrap prototype of requests. So it had like a method called, send prototype, and send prototype would take any prototype message, serialize it, put it inside, get its message type, put that inside a wrap request, and then write that to a socket. And it also knew, though, in PHP, there's no asynchronous anything. You need to just send that, and then you wait. You can set a timeout, and you wait for the response. And so we knew also, like how to get a response and parse it. We didn't, by the way, wrap the responses. If you remember here, I'm saying that we wrap the requests, but we didn't wrap the responses. Why not? Because, PHP is the only client. So if it's a synchronous thing, if you're sending a login request, you know that you should get a login response. There's not like there are many. You design things so that a particular request type should only have one response type. That's a limitation that we impose on ourselves, and that way we don't have to wrap the responses. We also handle timeouts, and we added some metrics so that we could know, because there was this concern about network time, so that we knew how long this was taking, right? The whole round trip to the Java service. Then we started, with these, we started working and spent the rest of 2017 writing services and using this as a way to communicate PHP with Java. Then in September, October of 2017, I checked back on the gRPC site, and there were big news. PHP was now supported. So I thought, this is great. And now we can use gRPC maybe. But then it said, yeah, we support PHP, but it's only PHP 7. And we were using PHP 5. And we tried to upgrade to PHP 7 because, it was like, can we upgrade so that we can use gRPC? And we tried to upgrade, but there was some weird bug that we found when we tried to upgrade to PHP 7 with parsing hex strings. And because this is a cryptocurrency exchange, Bitcoin addresses are encoded in a weird thing called base 58, similar to base 64. But Ethereum addresses and with Bitcoin, like the transaction IDs and there's a lot of hashes and stuff that is encoded as hex strings, and those made PHP 7 crash, like some of those strings. So it was a very weird thing, and we didn't have time to figure it out and solve that. So we stayed with PHP 5, and so we couldn't use gRPC. So we continued to use our own stuff. Now, in 2018, the team starts to grow and the software starts to grow. And suddenly, PHP is not going to be the only client because people are starting to write, like we need to develop new products and things. And more services come into play. And suddenly, we need some of these services to talk to the services that we already have. And then comes a big decision. What do we do? I mean, it doesn't matter if PHP does not support it, right? We're talking Java to Java. We could use gRPC. But then, this service, which I'm calling server here because it's client server scheme, this service already speaks one thing, which is our prototype over TCP sockets. We never gave this thing a name, by the way. But it's already using this. So why go and add gRPC to this one? So just so that this can, we're still going to use the other thing because PHP needs it. So I think it's more efficient if we just reuse that. And then we just need to write a client for this side. How do we write the client? And then we thought, in PHP, we had the product of trade, and that was good enough for that. But in Java, we can do better, right? I mean, if you look at the inside of this thing, it may mostly, these services look a little bit like this. You have the request processors, which I set handlers here, like the Netty handlers. And you have a business component or 2 or 3. And so what are you doing? It's basically the same thing as with a REST service. With REST, and I think maybe I'm getting a little philosophical here, but I think it depends on your perspective. I don't know if my brain works funny or what, but I see these things. I think most people look at these things from the outside in. Like, this is a service, and I talk to it by using there's a REST method with a URL, and I send it some JSON, and it gives it back to me. And that's what it does. And, but when you're writing these things, you look at it from the inside out. At least, I like to look at them this way. So you write a business component, let's say a login service, and you test it and it works. But how do you expose, how do you let people, other services talk to this component? You do it through these things, right? I mean, that's how PHP is talking to the business component. But if you look at it from the inside out, what you're really doing is exposing the behavior of the login service through these handlers that, through the protocol of requests that it receives. So you're exposing the behavior of this component. You're making it accessible. This is the interface. And then the word interface, right? Let's say that this component, a login service, is, it has to be, if you're doing things cleanly in Java, this is the implementation of an interface. So there's probably some interface somewhere called login service, and it defines a method called login with a username and password, and it has a login result. And then you're exposing this stuff, right? I mean, this login result is probably a class, like a DTO, with an either success or error, or what kind of error, or maybe even the user and stuff like that. It can contain these kind of things. It's a DTO. It's not a protobuf. These things should never contain protobuf, right? Separation of concerns and so on. So this should be agnostic to the transport. The handlers that are going to talk to this component, these ones should convert that login result into some login response and send that back over the, as a protobuf. But inside here, you don't even know about protobuf, right? You can give this to someone and like, please implement this, and they don't even know what you're using. I mean, you could rip this out and replace it with REST, and this should still work the same way. So on the client, it occurred to us that we could do something like this, just a different implementation of the login service, in which instead of going to the database and trying to fetch a user and then encrypt the password and compare it and blah blah blah, just do the same thing that basically PHP was doing, which is create a request, a protocol of request, fill it with data, send it over the wire. This thing has to know the host and port of the destination service, wait for a response, and then convert that response, probably a login response or something, to the login result object that you need to return externally, and you return that, and that's it. So this is how we started working to make Java services talk to other services. And a friend of mine, SuperSearch, if you're there, hi, he called these things protoschemes. So a protoscheme is a proxy that implements the same interface that is in a component in another service, and then the implementation is just talking to this service. And it's really neat because we were working in a monorepo environment, and so this service, it gave us another advantage. This service had when you work against interfaces, this is the beautiful thing about it. You have a component here that needs to talk to the login service. So it has a field of type login service, which is an interface. And when you run this in production, it will have the login service proto-shim connecting to this service. But how can you test this service? I mean, for testing, it's going to be kind of not very practical if you have to run this service in order to test this one. So what we do usually is, if you have the login service implementation that this guy uses, you can use it here for testing. So you replace the proto-shim in the test environment, you replace the proto-shim with the actual component, and you can test away. And you don't need to mock. I mean, because obviously the other solution is to mock things. But this way, you can use the real component, and because it's already implemented and tested elsewhere, you could use this one here. So that's how we've been working so far. This is what we have today. We are aware that today, last year we managed to finally upgrade to PHP 7. We could start using gRPC, but now the interesting thing is this, because we've been developing with this thing for almost 5 years now. I honestly have this question for you. Maybe it's gonna feel like a weird kind of talk because you can ask me questions at any point, but I want to ask you, if you're like gRPC experts, should we add gRPC into the mix? Should we continue using this thing? Should we aim to replace our stuff with gRPC, or should we just add it into the mix? What should we do? There are some, to answer this question, is not just about, hey, it's developed, it's a product that's been developed by Google and everything, and of course it's going to be better than yours, and you should use that one. It's also, what we have today is working, and it's working well. It hasn't been an issue. We've had crazy growth. We started developing this thing when we had like 25,000 users. Today we have a few weeks ago, we reached 3 million accounts. The volume has grown like crazy. The number of services, I don't know. I don't even know how many services we have running. Maybe it's like 50 or something. And they're all talking to each other with this thing. And we've had all kinds of issues, but bandwidth or response time from the network, like this particular component, has never been an issue. It has performed really well. And we know this because we added all this stuff to it. First thing we did was we used Micrometer, really cool library. So we are timing everything. When we get a request, we count it and we time, how long does it take to send the response, which is not the performance itself of this library, but rather, the component that needed to do things. But we do that, and we know about, there's a health check that we did, and we added some other bells and whistles, like if a service is going down because you're running in Kubernetes, if a service is going down, it's been taken off the load balancer, but you were still connected to it and you send a request, it will tell you that it's in the process of shutting down, and can you please drop that socket because it's ignoring requests now, and you need to resend it. And when you resend it, it's, it's likely to be sent to another pod that's up and running. So we have that. We added recently, thanks to Domix, who's today in the audience, we added the open tracing API. So we can do open tracing with these, and we use Datadog for metrics. And we added this thing to the wrapped request. So all the requests we know we can trace them from PHP to a service to another service and to another service, and we can see, how complex a request is, because it can trigger one service talking to another, but then one talking to another three, and so on, right? All triggered by the same event. Also, we added resilience for J to the clients. So this client, this proto-shim, the code is not as simple as this. This is just like almost pseudocode. In here, this send request, we use resilience for J. So we have circuit breakers between these two services, and that allows us to, so that if this service gets overloaded for whatever reason, maybe Elon Musk tweeted something stupid in the morning and people are flooding to buy or sell Bitcoin or whatever, and this service can get overloaded, it won't overload these other ones. They did that in the past, and that's why we added these things, right? Because this service would get overloaded and it would overload this one, which in turn would overload three other ones, which in turn would overload the databases, and things crash, and it wasn't pretty. By adding circuit breakers here, things were really smooth. Maybe one or two users get an error and they can retry, because everybody's got the F5 key, which is their favorite key, and they just retry, and they will, for the next time, they'll probably be okay. We have micrometer, resilience for J, open tracing API, and also recently, because things are getting complex enough that we are starting to introduce, we're introducing an event-driven architecture, using message brokers to try to decouple systems, because this thing is client-server, right? It's direct host-to-host communication, where you're sending a message, and it's not that one's better than the other. Both things work. You need some of those for different use cases, right? But we're pushing towards these, so it's going to be one more moving part in all these systems. And well, this is not like a requirement, just I wanted to mention this. Now, does it make sense to include one more moving part, which would be gRPC, considering that we're adding this one? And I don't know, honestly, if gRPC has all of these bells and whistles that we have added over time to our library, because we would need to keep, now that we have open tracing, we're not going to give it up, right? Now that we have resilience for J, we don't want to lose that. This has been working. We have been adding these things over time, and it's working really nice today. So I don't know. What do you think? So now I'm open to questions and for answers too. Thank you.
Thank you so much, Enrique. So if anyone has a question, we have also released a poll. So it would be very helpful if you could just fill it. And so let's just give people a minute just to think about their questions. But if not, anyway, we're going to upload this video on YouTube, so you will be able to, let me see, Srini. Srini, please go ahead.
Hi. Yeah. Yes. Thanks for the great presentation. I think it gives a very good historical background on, why gRPC was not chosen here. I think that initial issues led to developing your own in-house, framework, right? And then continue with that. But you asked a question about why not gRPC, right? And I think a few things that I can see here is that obviously not everybody can develop such framework. Not everyone has that kind of resources and time, right? Secondly, I think the recent developments in gRPC, which essentially brings in a lot of the so-called service mesh functionality. For example, circuit breakers is what you mentioned, right? So those things are all now, coming into gRPC through the service mesh functionality integration. So I'm not sure if you're keeping an eye on those developments, but the idea is that almost all the popular service mesh solutions out there, whether they're open source or whether they are being provided by cloud vendors, they're all pretty much standardizing on this thing called Istio, the Istio service mesh.
Oh, okay,
Um,
okay.
yeah, and there is a common control plane protocol, which is known as XDS, which is what is used to program your data plane from a control plane. So for example, if you want to send circuit breaking configuration to some clients, you can do it in a centralized way through a control plane, which basically can also set up variety of configurations to different clients in different ways. And then because this XTS protocol is kind of common between many service mesh implementations, so gRPC decided to implement the same thing. And now we are like, we have released like a bunch of features, like you can discover services, you can split traffic, you can do header path matching, and route your traffic to different services. You can do circuit breaking, you can do timeout, retry, and all those things basically.
Cool. Okay.
Yeah. So I think PHP is one common problem that I have seen where a lot of companies which uh, you know are old enough that they standardized on PHP monolith long time ago, and that becomes a problem to break it down and move it. Unfortunately, gRPC still doesn't have, I think, PHP server side support. So if you it's uncommon though, but usually the ingress is PHP, and then from there, if you are modernizing your application, then you go into using Java, Go, and other languages, right? Um, so I still think there is a lot of value being added to gRPC as we speak. So it's definitely worth taking a look and see, whether you want to build your service mesh from scratch, or do you want to leverage one of the open source, softwares, or you want to sign up with a control plane managed by a cloud vendor, basically.
Okay, that's interesting because these things, when I looked at, like, honestly, the last time I took a detailed look at gRPC was in 2017 when we found out we couldn't use it, and back then I don't think it had like this, like tracing and all this, the service mesh stuff. It didn't have it yet, but like I said, it was version 1.1.
Yeah.
And I suppose, I thought probably today it's been, I mean, if we could implement all of this stuff on top of what we have, I'm pretty sure gRPC has also grown and evolved, and probably has all these nice things. Actually, one of our DevOps team members was asking me today about, he mentioned the service mesh thing, and something else that seems that gRPC has. So it looks like our DevOps team would be eager to, for us to switch to
Yes.
gRPC,
I
because
think
it has some advantages for them.
right. If you have like, um, if your services are growing to a size where you need, like, for example, global load balancing, like you deploy your services in multiple regions, and oftentimes just the load balancing provided by Kubernetes is not sufficient. One example is, even if your cluster is spread across regions, for example, right?
Mhm.
How do you ensure that a request from a client goes to the closest service instance
Ah,
rather than just being spread blindly across all the instances of your service in a round robin fashion or whatever load balancing mechanism you choose, right? So
okay,
location aware load balancing is important because you want to keep your latency as low as possible. And these are some of
definitely.
the things that, open source solutions can't solve, because this is a control plane thing. This is the brains behind your service mesh, right? Which is you need to have global awareness of where your client is coming from, which region is the request being generated, and where is your server instance sitting, so that you can take the shortest route, right? And when the closest server capacity is filling up, then how do you start failing over or overflowing to the next closest zone in the same region? And if the zone fails, then how do you go to the next one, and so on, right? And those are the kind of things that you start to face when your service is becoming really big and you need regional redundancy, for example, right? Um, and then how do you do like health checks at a high scale? For example, if you have thousands of service instances, the Kubernetes has some scaling issues where health checks become problematic at that scale. That means you need a centralized way of checking health of your endpoints, and you want to quickly update the client saying that these are not available anymore, instead of client making a request and figuring out that a server is down or it's slow, or it's not going to respond quickly. Then you end up retrying to another backend, right? So all that logic you have to build in your own framework. But with service mesh, all these things basically come built in. For example, you can hedge your request so that you send it to not just one backend, but you send it to 3 at a time, let's say. And whoever responds the fastest, you use that response and discard the other 2, right? So there's a long list of features that usually when your business needs grow, your scalability needs grow, then you start seeing these needs, and then building them on top of the homegrown frameworks becomes quite time consuming.
This is really interesting. Thank you for that info. Hadn't thought about that, and wow, yeah, I think I'm sold.
Sure, no. Thank you.
Thank you so much, Srini. Thank you so much, Enrique. Okay, so as I told you, this recording will be on YouTube. And thank you for answering the poll. We will let you know about the next meetup. Remember the Data Lake Management meetup this Thursday, 10 a.m. Pacific time. And thank you so much for being here. We're looking forward to seeing you again. Thank you, Enrique.
Sure. Thank you for having me. See you
Bye-bye,
around.
everyone.
Thanks all. Bye.